Hello, good evening. How are you? Oh,
Fine, fine. How are you?
I'm all right. Oh, we're supposed to have chemistry, right?
Yes,
sir.
All right. Okay, so I'm tutoring you for the first time. This was your first maths tutorial?
Yes, sir.
Yes, sir.
Oh, all right. Okay. All right. So that's me there. In case, are you able to see me, right?
Yes, sir. I can see you.
Oh, all right. Yeah. So my name's Blessings Kasenge, and I'm a 7th-year medical student at Ridgeway Campus. Yeah. So I'm excited to tutor you guys in chemistry. Yeah, so chemistry is a very interesting course. Yeah, I actually had an A in chemistry in first year. So it's very possible to actually do well in chemistry. Yeah, it's one of the... Sorry? Sorry, what did I hear? Someone talked about the C or something, right? Oh, no, you guys, like, you can actually do it. No, you can actually do it. Like, I remember the time that I was in first year, I actually missed I think I missed a quiz. My CA wasn't so good. Yeah, but I think sometimes if you do really well in the exam, sometimes I may think I don't count the CA sometimes because my CA wasn't that good. But then I think I did well in the exam.
So how many percent, sir? You see,
Sorry?
you see, it was how many percent?
My CA was 35 out of 40.
Now 35.
Sir.
No, out of 50. Sorry. No. 35 out of 50. 35 out of 50.
It's still the same. He did well.
Yeah, so meaning like for me to get an A, I needed to get like almost everything in the exam, like close to everything. So I think it's possible for you guys to do really well. Yeah. So you guys are still being tutored by what's her name? Dr. Mrs. Prakash or something? She's still around. Oh.
No.
We have Mr. Langson. We don't have doctors these days.
There's Langson.
Oh.
Langson. Langson.
So there's no Prakash anywhere.
Yeah.
He's there.
It's off you.
Oh, I don't, but I think those were our lecturers those days.
She's here.
She's around, nice.
Yeah, she's around.
Yes.
Yeah. She's a very good woman.
So sir, you know Mr. Langton?
No, I don't. Mr. Langson? No, I don't. Oh.
Guys, behave.
What of Mr. Tempo?
No, I don't. I think I was last there, I think 6-7 years ago. So I think most of them have left.
Oh, wow.
Yeah.
Come on, put, let's go.
Yeah, so what topic are you currently doing in class?
Kinematics.
Chemical kinematics.
Chemical kinetics.
Okay, I think those, like, I don't know, maybe they can mute those that have the mics on. Okay. So chemical kinetics is topic number what? So chemical kinetics is topic number what?
I think that's topic number 5. I'm not
Number
mistaken.
5. All right.
Yes.
So you've done stoichiometry and the more concept, right?
Yes, we have.
And then you've also done empirical formulas.
Not yet.
Okay. Have you done chemical equilibrium?
No, not yet.
Not yet.
Not yet.
That's
Quantum.
after kinetics.
That's after the kinetics. All right. Okay. Yeah. So today we are going to do stoichiometry and the more concept, which I think is the first topic that you did, right?
Yes.
Yeah.
Yeah. One-dimensional analysis.
One-dimensional analysis. Yeah. So the first topic of chemistry, the stoichiometry, is the most important topic actually in chemistry, because everything that you'll be doing basically be building on this very topic. So if you can't fail to miss, like you can't miss this topic. Once you don't really understand this topic, it means that the rest of the chemistry course is going to be a bit challenging. So please try to understand this topic. Remember the time I was in first, I found Zoomda very useful. So you can just do basically all the examples that are in Zoomda, and then you also attempt the exercises that are there. And I know Zoomda's got some answers behind. So you could attempt some exercises and check the answers, mark yourself. So chemistry is also literally about practice. So you have to do a lot of practice, especially on the more concept, because it's a foundation for everything, right? All right, so we can start. So I don't know, what do you understand by stoichiometry? Maybe someone can just try to answer. What do we understand by stoichiometry? Anyone? I'm allowed to point, right? I'm not allowed to
Yes,
point.
sir.
I'm allowed to point, right?
No.
Yes, you are allowed.
Yes, sir, you're
Okay.
allowed.
Okay, Teresa Ngandu. Is Teresa around? The way you guys go quiet, like you're not hearing, but you're hearing. All right, what about Andrew Njamba? Natasha Chivolia?
But doesn't have.
Let me try, sir.
Yes, you can go ahead, Natasha.
Stoichiometry is the study of quantities of materials.
Yeah, so very good, Natasha. So basically that's that. So stoichiometry, so there are two words there. There's stoichio and metry, right? So every time we hear of metry, we think of measurements. And stoichion actually comes from a word which means elements. So stoichiometry basically refers to the measurement of elements, or as Natasha says, the quantity of elements. And these elements could be physical elements and chemical elements. So that's what basically we'll be doing in stoichiometry. So that's basically the basic definition of stoichiometry. So the first thing that I would want us to look at is significant figures. You did significant figures, right?
Yes, sir.
Yes.
Yeah, so significant figures are very important. Actually, I think questions every year on significant figures, the very first, you wrote your test ones, right?
Yes, we did.
Yeah, the test ones are the ones that are usually bad. I know the results were probably bad. Yeah, so the significant figures will always be there. You always be asked to round off to the nearest what. You always be asked the number of significant figures, and so you'd want to get the significant figures right. Yeah, so the rules that I would love us to look into when it comes to finding out the number of significant figures in a particular value. So the first rule is that the numbers 1 to 9 are always significant. Hey, that is clear, right? Yeah, so the numbers 1 to 9 are always significant. So that is the first rule. So you take note of that. And then the other rule also is that the numbers or zeros that are coming after a significant figure are also significant. For example, if you're given a number like 25.00, the zeros are coming after the 5, which is a significant number. So the zeros are also going to become significant. So meaning 25.00 has got 4 significant figures. That is clear, right?
Yes, sir.
Can you repeat, sir?
Yes.
Yeah, so I said zeros that come after a significant figure and a decimal point are always significant. So for example, if you're given 25.00, you know that the zeros are coming after a decimal point and the zeros are also coming after a 5. So the 5 is a significant number because we said in the beginning that the numbers from 1 to 9 are all significant. So numbers between 1 and 9 are all significant. So in this case, 25.00 has got 4 significant figures, the 2, the 5, and the 2 zeros after the decimal point. So that's clear now, right? All right.
Yes.
So if you're given something like 3 and 5 zeros, so 3.0000 with 5 zeros, how many significant figures do you think that is?
Sir, can you repeat? I didn't get.
Repeat.
Okay, so if you're given 3 point and then there are 5 zeros after the decimal point, so altogether, how many significant numbers are those?
6.
6. Yes.
6.
Yeah. So the zeros after the decimal point, the 3 is a significant number, so the zeros also become significant. So there are 6 significant figures. So what if you're given a number like 30,000? How many significant numbers are there?
1.
1.
Yeah.
30,000. 1, right?
Sir.
Yeah.
1.
So as long as there's no decimal point, only the number that's at the beginning, which is 3, is a significant number. The other zeros are not significant. So we've gotten those 2 rules, right?
Yes, we have.
Yes. Yes, sir.
All right. Then another thing, another rule now is that whenever you're adding 2 numbers that have got different numbers of decimal point, you always consider the decimal point. You always consider that number that has got the least number of decimal point. So, for example, if you're given something like 2.2 plus 4.53. So 2.2 plus 4.53. You know the number is 6.73, right?
Yes, sir.
Yeah. So in that case, when rounding off to the nearest decimal, we consider the number that has got the least number of decimal places. In this case, is 2.2, which has got 1 decimal place. So meaning our answer should also only have 1 decimal place. Is that clear?
Yes, sir.
Yes, sir.
Yeah. So as opposed to 6.73, our answer is 6.7 because the number with the least decimal place is 2.2. So in that case, we only get 6.7 as our answer. So that's also another rule. I'm sure we've got it, right?
Yes, sir.
All right. And then another rule also is whenever we are multiplying or we are dividing 2 numbers that have got decimal places. So for example, if you have been asked to multiply 0.033 multiplied by 0.002500. I don't know, you guys have got calculators, right?
Yes.
Do you guys have calculators?
Yes.
All right, so someone can multiply 0.033
0.033
multiplied by 0.
Yes.
Multiplied by 0.0025
0.0 what?
0.0025
8.0.
0.025
00. 00 at the end. So what's the answer? What answer are you getting?
8.25 by 10
You're
saying we multiply
-5.
scientific notation.
Yeah, so now remove it from scientific notation and put it in the normal way so that we get I want us to get the decimal point.
It's 000 4 zeros, 825.
82500 at the end. Okay, yeah. Okay. So whenever we're multiplying like numbers like that, so we always get the number that has got the least number of significant figures. So our answer should have the number of significant figures in our answer should be equal to that number that has got the least number of significant figures. I don't know if you've got that. So if you look at 0.033, how many significant figures does this number have?
2.
It's got 2, right? And then if you look at 0.002500, how how many significant figures does this one have?
4.
Yeah, so this one has got 4 significant figures. So our answer should only have 2 significant figures. So our answer should have 2 significant figures. So the number of significant figures in our answer should be equal to the least number of significant figures in the equation. So in this case, the least number was 2, right?
Yes.
Yeah, so our answer meaning is going to be 0.00083. So you know it was 825, so we can simply add 1 to the 2 to make it 3, right?
Yes.
Yeah, so that's also another rule. Whenever you're multiplying or whenever you're dividing, that's another rule. So we've gotten that rule, right? Yeah.
Yes.
Then another rule also, whenever you are dividing, for example, you're dividing physical constants. You've heard of physical constants in chemistry, right? Like for example, the Avogadro's constant. So that one is a constant, like it's already there. You're simply getting it. For example, the atmospheric pressure, gravity, all those are constants. So whenever you're dividing a constant, you don't consider the constant. Whenever you're finding the number of significant figures in your answer. So leave the constant alone, just focus on that number that you're using to divide. And your answer should have the same number of significant figures as that number and not the constant. So just ignore the constant. So for example, if you've been asked to maybe divide 0.2512, divide by 1.01. So 1.01 is the atomic number for hydrogen, so it's a constant. So whenever we divide this, the answer that we get should have the same number of significant figures as 0.2512. So we forget about the constant. We've gotten that true, right?
Yes.
No, sir.
Yes.
You haven't
Yes,
gotten it.
sir.
Okay, let me repeat for those that haven't gotten it. So whenever you're dividing, for example, constants. So in this case, for example, 1.01 is a constant because it's an atomic number for hydrogen. So for example, you've been given to divide, let's say 0.2512 divide by 1.01. So remember in the previous rule, we're saying that your answer should have the same number of significant figures as that number that's got the least number of significant figures. So in this case, if we were to follow that rule, we'd have to get 1.01, which has got 3 significant figures, as the number, and as the answer that we find would have 3 significant figures. But in this case, we're saying that the 1.01 is a constant. So we don't consider it, we ignore it. Instead, we just follow that number that we were using to divide. In this case, it was 0.2512. So I'm sure we've now gotten it, right?
Yes.
Yeah, it's clear now.
Yeah, it's clear now. All right. Then the other rule is obviously the rule that we have been following, I think, from grade 12, where we have been given 2 numbers, rounding off. If it's greater than 5, greater than or equal to 5, we add 1 to the previous number. That one is one rule that we all know, isn't it, right? Yeah, so that's about significant figures. So please make sure you revise. Make sure you know these small rules, because these should be free marks in the exam. At least before you start solving the harder questions, make sure you clear out the significant figures, you get them right. These are also asked even in physics. So you're not only knowing them for chemistry, but you're also knowing them for physics. All right, we are good on that one, right?
Yes.
Yes.
All right, so let's now look at the SI units. So in chemistry, you need to know the SI units firstly before you do anything, because everything that you'll be calculating, you would have to be rounding them off to the SI unit. So there are questions where you're given, for example, maybe you're told, maybe multiply maybe the length times the distance. So you find maybe the length is in centimeters and maybe the volume is in milliliters. So those are not SI units. So before you proceed for that question, you would have to first convert the length into its own SI unit, as well as the volume into its own SI unit. So what's the SI unit for length?
Meters.
Meters. For mass,
KG.
kg for mass, kg for time,
Seconds.
for temperature.
Kelvin.
How many kelvins make up a degree Celsius?
270.
273. Okay, great. Gosh, you guys, you know this thing. All right. Then electric current, what's the SI unit?
Ampere.
Column. Amps.
Amps, right? Ampere. Then the amount of substance, what's the SI unit?
Meter.
More.
Moles.
Degree.
Moles, right? Moles. And then for luminous intensity,
Candela.
candela, great. Yeah, candela, CD. Yeah, so you have to know those SI units. So whenever you're solving, you'll be converting to the SI unit. It's safer that way. You always get it right if you convert it to the SI unit. Unless they tell you to say maybe they want the answer in degrees Celsius. That's when you convert to that, but always convert to the SI unit. It's safer that way. All right, then you guys also did prefixes, right?
Yes.
Yes, sir.
All right, so you guys know what's 10 to the power 12? What's 10 to the power 12? Sorry? 10 to the power 12. What's the prefix?
Figure.
10 to the power 6. 10 to the power 12. It's a trillion, right? Trillion.
Yeah, 1 times 10.
It's a trillion, right?
Yes.
Yeah, then 10 to the power 9.
Billion.
Yeah, 10 to the power 9 is a billion. 10 to the power 6 is a million. 10 to the power 3 is 1,000. 10 to the power 2 is 100. So what's 10 to the power 0?
It's 1.
All right, then 10 to the power 10 to the power negative 1. It's 10, right? I think maybe those that have their mics on can kindly mute. There's a lot of background noise. All right, so you need to know the prefixes really well. At times they may ask you to convert to a particular prefix, and then if you don't know it, then you definitely get the answer wrong. Yeah, so then let's also look at precision and accuracy. So who wants to tell us the definitions, and who also wants to explain the difference between precision and accuracy? Anyone? Precision and accuracy, anyone? Okay, I point.
Precision is how close
Maggie, okay,
measurements
okay.
are to each other.
Okay, yes.
Wow, accuracy is how close measurements are to true value.
The true value. All right, great. That was Jethro, right? Maggie, do you have a question?
No, I was trying to define precision and accuracy, but then someone has already defined, so it's fine.
No, you can give us a definition. It's still fine.
It's same, Kylie. It's the same thing, so it's okay.
Maybe you
Just
can
say.
say it in a different way.
Okay,
All right,
precision.
okay.
Precision is more like finding an answer that's close to, more like, no, accuracy is finding an answer that's close to or more like the actual value that you're supposed to find.
All right. Yeah.
And then yes, precision is, I'm not sure about precision, but then for accuracy.
All right. Okay. Yeah. So basically, it's what Jethro said. So precision is how close values are to each other, and then accuracy is how close those values are to the true value. So maybe I can give an example. If I ask 3 guys, or maybe 3 of you guys, to go to Unza, and then the 3 of you all end up in town. So there's good precision, but there's bad accuracy. You get it, right? Because the true value there is Unza. That's why you're supposed to end up. But all of you guys ended up in town. So the precision is good, but accuracy is bad. You get it, right? Yeah. And then the accuracy is where maybe if I ask you guys to go to Unza, maybe one lands at East Park, another one maybe lands somewhere by Zesco, maybe another one is somewhere in town. So in that case, the one that's most accurate is the one that's closest to the true value. So accuracy, always think of the true value, know what the true value is, look at what is closest to the true value. That value is the most accurate. For precision, look at how close values are to each other. Right? So have we understood the differences between precision and accuracy?
Yes.
Yes, sir.
Yes, sir.
We've understood. So if they ask that one, we're going to know.
Yes.
All right. So that was an introduction. So the next thing that we can look at now is we can now delve into atoms, molecules, and ions. So what is an atom? In the simplest terms, what is an atom?
Smallest element.
Smallest.
A smallest indivisible particle that takes part in a chemical reaction.
All right, that sounds more like your university definition. Smallest particle. See, I'm grade 2 of you. Yeah, so at least we'll take a chemical reaction somewhere. The smallest something that can participate or that can take part in a chemical reaction. Yeah, then we know that okay, these guys are now freshers, they're now at the university. Yeah, so that's basically an atom. So who can tell me what is made up of an atomic, what makes up an atomic structure, basically, before we go on?
Protons, electrons, and neutrons.
Yeah, so an atomic structure is made up of protons, it's made up of electrons, it's made up of neutrons rather. So which ones are positively charged and which ones are negatively charged?
Protons are positive.
Protons are positively charged, while electrons are negatively charged.
All right, so always P for positive, protons are positively charged, electrons are negatively charged. The neutrons, what charge do they have? All right, so neutrons for neutral, so they've got no charge, they're neutral. Yeah, another thing that you'd also want to know is you'd want to know the molecular weights for each of those, or maybe should I say the units for an electron, the units for a proton, and then as well as for a neutron. Because sometimes you may not be given this, so you may just want to memorize just how much one proton is, how much one electron is, and how much one neutron is. Is there anyone who has memorized those values? Anyone has memorized?
Both carry the mass, I think. I'm not sure, but they both have a mass.
They carry what?
One.
They both have a mass of?
One.
One exactly.
Yeah.
I think it's 1 point something.
Okay, then electrons, it's negligible, or it's 1 over. Let me just say negligible because I haven't mastered that number.
I think some.
Sorry?
It's 1 over 1840.
1 over 1840. Okay, yeah, but So if you calculate that, I think for an electron, it's going to give you something like 9 point something times 10 to the power negative 28. The power negative 28, right? Okay, 9.1 times 10 to the power negative 28. That's for an electron. No,
27.
negative 24, 27, 24.
It's 1.6 times 10 to the power negative 27.
Oh, not 24.
No.
All right, so you should check that one out, either 24 or 27, but I think I remember 24. Yeah, so those values, make sure you know them. Sometimes you may not be given those values in the exams, so make sure you just know them by heart so that you just get to use them. All right, so we're clear on those, right? So electrons, know the charges, the protons, the neutrons, and the electrons. Please make sure you know those charges. Those charges will always come back to haunt you in second year, and even when you come here at Ridgeway, the third year, they'll still be asking you about these same things. Which ones are positively charged? Which ones are negatively charged? So you just want to make sure you know these things right from the beginning, like right from first year. All right, so let's also look at isotopes, atomic, as well as molecular masses. So who can tell us what is an isotope?
Yeah, an isotope, we can say these are elements of the same atomic number, but different neutrons number.
All right, so same atomic number, but different neutron number. Anyone with a different answer? All of us agree, right?
Yes.
Yeah. So I know in first year it's really hard to tell like what's the difference, like what's the importance of these same isotopes. So actually, when you come when you come over to this side, yeah, there are different isotopes. For example, there are certain diseases like, for example, hyperthyroidism or those with goiter. So we use different isotopes. Other isotopes can be used to diagnose the problem. Other isotopes could even be used to treat. So basically, these are elements, same atomic number, but they've got different neutron numbers. So these isotopes are very, very important. They are more to do with radioactive isotopes. They are very important in certain diseases. They can be used to make diagnosis. They can also be used to treat. So it's important that you know most of these and you know the exact definition, because it will be easier when you come here. You will know to say, okay, I'm talking about an isotope. I know what an isotope is. Yeah, so basically that's that.
So I have a question.
Yes, go ahead.
Yeah, since an atom has the number of protons and the number of electrons, so can we define an isotope as these are elements of the same electron number but different neutron
Yes,
number?
you can.
Yeah,
you
excuse
can.
me.
Sorry. Yes, go ahead.
What's an isotropic? What's an isotropic?
Isotropic.
Yeah.
Isotropic, I haven't come across it. I don't know if any of you guys have come across it. I don't know. Has any of you guys come across it? Isotropic?
If it's isotropic or isotropic.
Is it I think it should be isotropic. Isn't it isotropic?
Yeah, something like that.
I need to check that one. Yeah, isotropic. I need to check that one. I can't remember, but I know there's something like isotropic and isotopic. Yeah, but they can, if you want to know it, you can know it. But I think they can rarely ask you about isotropic. Mostly just focus on the isotopes. Really, mostly. They can ask you to define what an isotope is, and then you can go ahead and define. Rarely can they ask you about isotopes. Rarely. All right. So, what's the formula that links the mass number, the number of protons, and the number of neutrons? Can someone tell us? Is there a formula that links these three? The mass number, the number of protons as well as the number of neutrons?
Yes, there is.
Yes. What's the formula?
A is equals to Z plus N.
A is equals to Z plus N. The A signifying what?
Mass number.
Yeah, A signifying mass number. Then the Z is signifying the number of protons, and the N is signifying the number of neutrons, right?
Yes.
Yeah, so this formula, guys, just make sure you know it. They can ask you, they can give you a number of protons, they can give you a number of neutrons, ask you to calculate the mass number, or they can give you either of them. So you need to know how to maneuver around this formula. It's like a very important formula. So make sure you put this one to memory, guys. That's clear, right?
Yes.
All right.
Loud
So
and
we can
clear.
now go into the more concept now. They can do an introduction of the more concept, the mores as well as the more concept. So who can define what a more is? Anyone? Anyone to define?
The more of defining a more is,
I think the
amount
others
of
that need to mute themselves. Bondwani, Esnat, Alik. All right. Okay, you can go ahead now and answer. What's a mole?
A mole is a quantity of substance that have got 6.022 times 10 to the power 23 particles.
Okay, that's another definition. Another definition.
Can you say it's the number of particles?
So define a mole as the amount of as in exactly 12 grams of carbon 12 isotope.
All right. So yeah. Who's Beast Boy? Beast Boy, your hand is up.
Yeah, it's the amount of substance that contains as entities as the number of atoms, exactly 12 grams of isotopes of carbon.
All right, great. So there are two definitions that have come across. So there's one where you guys are talking about the amount of substance that contains as many entities as there are in 12 grams of carbon 12 isotope. So that's another definition. Another definition is the one that was given by Ali Dawa. She said, she simply said one more is equals to 6.022 times 10 to the power 23 units. But almost 3 more that are remaining, I think. 3 more. Almost 3 or 2. Let's go, guys. Another one. Let's go. So another one is number of moles. Okay, let's go. Who wants to say?
For the number of moles.
Yes.
What of molarity times volume? There is not.
Yes. Molarity times volume. Very good, Charles. So number of moles is equals to molarity times volume. That's also another one. Any other one? Okay, this one is for the Jobbies now. Jobbies, this is why you come, you unleash your potential.
I think the other one is for, is it for gas pressure, something like that?
Yeah, that one is for pressure. You need to know that one also because you haven't done pressure, right? Have you done pressure?
No, for us, no.
Oh, okay. So you're going to do pressure at some point. So you need to know this one. So does anyone know it?
Yes.
Yes. Give us.
It's equal to N is equals to P times V over R times T.
P times V over R times T. So you've Googled that one, right? So what does a P represent?
Pressure.
pressure, and then the V.
Volume.
Volume, then the R.
The constant.
Constant for what?
I forgot this.
Yeah, so the R is the atmospheric pressure. It's a constant, as you have said. So you need to know also the constant, the actual value for the constant for the atmospheric pressure. You need to know that one, that most likely that they're going to ask you. You heard, right?
Yes, sir.
All right, then the T is the temperature, of course, in Kelvin. So all these, make sure they are in their correct SI units. We're good, right? All right, so
Yeah,
I can give you some examples to work out. What's the time now?
It's 1843.
1843. All right, let me give you about even two or three examples to just work out. That's fine, right?
Okay.
Yes, sir.
Sorry?
Yes, it's fine. You can give us.
All right. All you guys are tired. You're exhausted from the mathematics. Let's just do a few examples. We're almost done.
No, you can continue.
So,
all right. So, sorry. Yes, then go ahead.
Yeah, you were saying something like there are about five formulas. Now, this one is what?
Also, I said the number of moles is equals to mass over molar mass. That's one.
Yes.
Then the number of moles is equals to molarity times volume, which is 2.
Yes.
Then the number of moles is equals to the PV over RT, that's 3.
Yes.
And then the number of moles is equals to concentration over volume, that's 4.
Yes.
And then there should be a fifth one. The number of moles is equals to the number of atoms over the number of atoms in 1 mole. You got that one, right? Yeah,
Yes.
that's the fifth one.
So
yeah.
Okay,
So once you know these 5 formulas, then you will never fail to calculate the number of moles. You will never fail, because these are the only formulas that they'll ask you about. They'll just play around with these same formulas and ask you. So just make sure you get to know these formulas, and once you get to know them, then you're good.
Okay, thank you.
All right. So let me give you something to calculate. So there's an example here in one of in the tutor sheet. So they're saying that calculate. Okay, let me give you one. What would be better? Okay, so calculate the number of moles for 5 times 10 to the power 20 cobalt atoms. We've got that one, right?
No, sir. Repeat the figure.
Okay, so calculate the number of moles for 5.00 times 10 to the power 20 cobalt atoms. We've got the figure, right?
Yes.
No, sir.
Sorry,
So
repeat the question.
calculate the number of moles for 5.00 times 10 to the power 20 cobalt atoms. All right, I'm sure we've got it, right? So I can now wait for you guys to calculate. Eh?
No, sir.
Yes, sir.
Eh?
Repeat, sir.
Okay, so calculate the number of moles for 5.00 times 10 to the power 20 cobalt atoms. All right, so whoever finds the answer can say it first.
Okay.
8.30 times 10 to the power 4.
Sorry?
8.30
Yes.
times 10 to the power 4 moles.
Times 10 to the power 4 moles of cobalt.
Yes.
All right, a different answer. I'm still waiting for other answers.
8.3 times 10 to the power times 10 to the power.
Okay, who's speaking? So that we just hear. Alida. Alida.
Yes, the question is that what's the difference between molarity and concentration? You say
Sorry?
number of moles. Between molarity and concentration, what's the difference?
Between?
Molarity and concentration.
Molarity and concentration. So molarity has got a component. Molarity is basically, I can say it's good. It's basically, okay, molarity, if you look at molarity itself, the formula is, or let me say the unit for molarity, moles over volume, right? So there's the volume aspect that's involved. So it's basically the number of moles, and then you're also looking at the volume. So looking at how much you've diluted, looking at the volume and the number of moles that you've added, that's the molarity. Well, mostly the concentration really doesn't focus much on the volume. It's mostly just the number of moles, really. That don't really focus a lot on the volume. So they're basically almost the same, but they're not really the same. So mostly the molarity, think of it more of as a volume.
All right, thank you.
All right.
I have a question.
Yes.
What are the units for? Is it for concentration?
Sorry?
Are the units for concentration?
So the units for concentration is also moles over volume, isn't it? Because you know that.
Yes.
No, not is it moles over volume, right? Yeah, moles over volume, which are basically the same as the molarity. So the molarity and the concentration are almost the same.
What's the difference?
They are the same.
Yeah, okay, they are, I can't really say they are the same. Okay, there is some difference. There is a difference, because if you look at the concentration, you're going to find that the concentration is actually equal to the number of moles times the volume, right? You got it right? So the concentration, you're going to find that it's equal to the number of moles times the volume. But if you look at the molarity, you're going to find that the molarity is actually the volume divided by the number of moles. You get it right? I don't know, have you got that?
Yes, sir.
Yeah, so if you look at the two formulas that we gave for the number of moles, we say the number of moles is equal to the concentration over the volume. We also say the number of moles is equal to the molarity times the volume. So in this case, if you make the concentration as a subject of formula, you're actually going to find that the concentration is actually equal to the number of moles times the volume. And if you make the molarity the subject of the formula, you're going to find that the molarity is equal to the number of moles over the volume. So both of them are involving the number of moles and the volume, except that for the concentration, we are multiplying the number of moles and the volume. For the molarity, we're dividing the number of moles by the volume. Have you got that, right?
Yeah.
All right, so great.
So what was the answer for the example?
Yeah, so only one person gave me the answer. He said 8.30 times 10 to the power 4 moles of cobalt. So I'm still waiting for other answers.
8.30 times 10 power negative 4.
Times 10 to the power negative 4?
Yes.
All right.
Yes.
Yeah, so that is the correct answer. 8.30 times 10 to the power negative 4 moles. So I think the first one didn't put the negative 4. I don't know how we calculated, but it's supposed to be 10 to the power negative 4 moles of cobalt.
I
You
have
got
a
that right?
question.
Yes, go ahead.
The 5.00 times 10, is it to the power negative 20 or to the
No,
power
it's
20?
just to the power 20.
Okay.
It's just to the power 20. Yeah. So we used the last formula I gave, right? The number of moles is equal to the number of atoms divided by the number of atoms in 1 mole, right?
Come again.
Is that the formula we used? The number of moles is equal to the number of atoms divided by the number of atoms in 1 mole. Is that what we used?
Yes.
Yeah, so we divided the 5.00 times 10 to the power 20, which is the number of atoms, and we divided it by 6.02 times 10 to the power 23, because that's how much 1 mole is. Right,
22.
isn't it?
That's 22.
10 to the power 23.
Yes, sir.
It's 23, right?
Yes.
All right,
Yes, sir.
so that's the answer. So that is very good. So the next question, we're ready for the next question?
Yes, sir.
Yes, sir.
Yeah, so next question, how many moles are in 0.2512 grams of hydrogen atoms?
Come again.
How many moles are in 0.2512 grams of hydrogen ion or of hydrogen atom sample?
Please repeat the question.
So how many moles are in 0.2512 grams of hydrogen atom sample?
Two 2.48 times 10 to the power negative to the power 9.
Sorry?
2.5 times 10 to the power 9.
2.5 times 10 to the power 9. Okay, anyone else? Anyone else?
0.1246 or 0.12.
0.2487.
0.12.
0.1?
2.
0.12. Okay. Another answer?
0.25.
0.25?
0.2487.
Okay, there's 0.2487. Okay, so I've received a total of 4 answers. There's one which is saying 2.5 times 10 to the power 9. There's another one who said 0.12. Another one said 0.25. Another one said 0.2487. So who said 0.2487?
Kunda.
Kunda, all right, Kunda, congratulations, you got it right. Yeah, so basically here we are using the formula number of moles is equal to the mass over the molar mass, right?
Sir,
Correct.
doesn't that depend
But sir, he used the rounded off figure, and we have been advised to use the one that's on the periodic table. That was published earlier on.
And what's the one that's on the periodic table that was published?
It was 1.00794.
007 1.00
794.
794.
Yes.
Yeah, and then if you use that, what answer did you find? Because you're supposed to get 0.12.
Yes.
No,
sure?
that gives you 0.249.
Yeah, something like that.
You were even advised to round it off to 4 significant figures.
Yes, do you remember also that rule that I said?
1.008.
Remember
right?
the rule that I said. So in this case, our mass is 0.2512. And then the molar mass for hydrogen, we can get it at 1.01. So in this case, the 1.01 is a constant. So meaning our answer should have 4 significant figures. Remember what I said, the rule that I said? Remember it, right?
Yeah.
Yes. So that's why the answer is actually 0.2487. 4 significant figures, because the hydrogen is a constant and the number we are dividing with is 0.2512. It's got 4 significant figures. So therefore, our answer should have 4 significant figures. Sorry?
Repeat the question.
You're saying how many moles are in 0.2512 grams of hydrogen atom sample?
Okay.
You got it right?
Yes. I followed the diatomic hydrogen. That's why I got it wrong.
The diatomic. Oh, okay. All right. All right. So just follow this. Just one hydrogen in this case, unless they've mentioned or unless they've given you to say it's H2. That's when now you can actually do those calculations.
Yeah. So for the number of significant figures, which one are you following?
So you follow the
0.25.
Yes, you follow the 0.2512 because the hydrogen, the constant, is a constant. So remember I said ignore the constant, only concentrate on that value that you have been given to divide, right?
Okay.
Yes, so that was the answer. So yeah, so let's just remember the rules for significant figures. All right, I don't know, are there any other questions?
I have a question.
Yes, go ahead.
It's still not clear about the molar mass.
Yes.
Which one are we?
Okay, like for me, even if you follow the same 1.00794, you still get something very similar. Either you're going to get 0.2490 or you're going to get 0.2, but it's going to be around those areas. If you use 1.00794, I think you're going to get something like 0.2490, right?
Yes.
Yeah, and then if you use 1.01, you're going to get 0.2487. So they're almost the same. We'll mark both of them in that case. Yeah, but as long as just make sure your answer has got 4 significant figures. All right, we're clear, right?
Yes.
All right, so it's 19 hours and our tutorial is done. Yeah, so I think you guys should just go ahead and practice, know these things, the significant figures, know that my formulas for number of moles, know that my constants for electrons, protons, and everything that we've talked about. All right? Yeah, I hope you guys enjoyed the tutorial. Yeah, I haven't tutored in a very long time, so I really tried my best to, yeah, I did my best, and I hope you guys enjoyed. Until we meet next time.
Thank you,
We
sir.
enjoyed.
Thank you so very much.
Thank
Enjoy.
you very much.
All right.
Bye.
Bye. All right. Bye.
Bye.